Hello, this is your host, Ray Lemming, on our video podcast, Dozers to Drywall, here at the Illinois Institute of Technology. This is actually our third video podcast we've put together, and we're starting to kind of get the hang of this. Today, I happen to have the head of the Civil Engineering, Architectural Engineering Department here to interview and talk about a few things. Dr. Brent Stephens has been in charge of our department, I think, for 10 years now. And he's also run the architectural engineering program here. So we're going to talk about those first two things first. But Brent, what's it like being a department head in a university?
Oh, that's a great question. Thanks for having me on. And thanks for taking this initiative. First and foremost. But yeah, that's a great question. What's it like being a department head? Well, I'm a department chair rather than a head. That is apparently a difference.
I guess my industry shows through. I'm not that political.
Yeah, one has power and one doesn't. So you said it's been 10 years. It only feels like 10 years. So it's been since 2018. So I think that's right though. 7 years feels like about 10. You know. Okay. So I think you calculated it like dog years, like chair years. But it's wonderful. I mean, I think it's, I think you do end up kind of, in the middle, in the middle of students and faculty, in the middle of deans and faculty and staff and that sort of thing. So you probably, I think other people in middle management and other areas in your career probably have similarities there. But as much as anything, I mean, I took the job fairly early in my career, mostly just because I've been here about 6 years to start my career, and an opportunity came up to lead and try to steer us, in some new directions. And sometimes, the deal, you look in the mirror and say, well, do I want someone else to do that, or do I want to do that? So I think I can do that, but mostly because I think we have a great department with great people, and that includes yourself. If you weren't here, I probably wouldn't do this, right?
Because I twisted your arm to do the video.
Yeah. Really, we got amazing faculty and amazing staff and amazing students, so everyone is really mission driven and passionate about what they do. So it makes that part a lot easier and a lot more rewarding to try to lead, or if anything, just get out of your way.
Yeah. Well, and as I said, you run the architectural engineering program here, and I know you got your PhD at the University of Texas, where I built the interstate highway out front. You were in the building doing academic things, but I found it somewhat interesting. Early in my career, I didn't know what an architectural engineer was, and a little bit of reading and research, I found out it originally came from, in Great Britain, the architects didn't want to do engineering, so they created these people to take care of that. In the United States, it's kind of done with either architectural schools or in some cases engineering departments, and we're one of the few that does that. And I know one of the big areas that our students work in are HVAC and that, and some of your research has been in those areas. And so why don't you tell us a little bit about architectural engineering?
Yeah, great. Yeah, thanks for that. That is certainly something that drew me here to Illinois Tech in the Civil Architectural and Environmental Engineering Department. I don't actually have an architectural engineering degree to my name. I have a bachelor's in civil engineering, a master's in environmental engineering, and then my PhD was in civil engineering, but really it was an architectural engineering topic. It was like building science and building systems and interactions with indoor air, air quality in the environments where we spend most of our time. I actually was drawn to Illinois Tech's architectural engineering program. I applied here for graduate school out of undergraduate because I was doing civil engineering and I liked it well enough. I had an internship like testing concrete And we need people to test concrete, and we train people to test concrete. And I love people that love to test concrete. I didn't want to test concrete for my career. I wanted to do something a little different. I got really interested in energy efficiency in buildings, first and foremost. I actually did an internship at a place called South Face in Atlanta, which is a nonprofit. Not a lot of engineers on staff. They've got a few, but it was kind of an opportunity to learn about green building programs and how to build and operate buildings a little bit more energy efficient. I focused on residential buildings there, and that kind of set me up well for my graduate work. So actually, when I finished my graduate work, I was applying to jobs, and all of a sudden here in Chicago, Illinois Tech's architectural engineering program has a position opening. I thought, oh, yeah. I was already interested in that 6 years ago. So it's been great. I love the field because it is kind of this intersection of civil engineering, mechanical engineering, environmental engineering with like a dash of architecture, just a dash, So there's only maybe 25 accredited undergraduate programs in the country for architectural engineering. I think we're probably in the biggest city, that has an architectural engineering program. So it's such a beautiful place to study this and other things in the heart of Chicago and the AEC industry. So yeah, it's kind of this unique blend of structures, and you understand the mechanical or the physical properties of a building, and then you get this exposure to MEP, the mechanical, electrical, plumbing. You understand kind of the guts behind the drywall, if you will, which I think is why they're rooted in civil engineering programs and departments, quite often. Because it's still behind the scenes. It's still like sort of building infrastructure. It's just at the building level. And then you get a little exposure to architectural design, which is important, and you got to work with architects. I think that's really key. Less linear, a little bit more working together early and often. And then, of course, you get exposed to your discipline in construction management. So I was thinking about your podcast and the name, From Dozers to Drywall.
Yeah.
And I'm thinking, this is good. This is construction in a nutshell. A lot of what we train in civil and architectural engineering is all the stuff that comes before the dozers.
The design side.
The design side, yeah. And then, as you know well, increasingly, after the drywall, we come in, right? And commissioning and making sure, measurement and verification, make sure buildings are operating the way they're meant to be. So yeah, I think across CAE, I feel like today it's like from design to dozers to drywalls to commissioning or something like that, But that's the broad.
Well, as an aside, Mohammed and I definitely intend to be teaching the commissioning course this fall.
Oh, great.
We've put it in the catalog and been working on the guts of it, and we think we're going to see that take off. But one of the things that I'll throw back at you on architectural engineering is when we look at buildings, say 1950, 1960, we used to have paperweights on our desk because you opened the windows to stay cool and the breeze blew your papers everywhere. And since that time, air conditioning and the heating systems have become standard, and the real key to it has been the computerization. Things that at those days, a fire damper had a lead chain on it, and there was a fire, the lead melted and the damper closed. And today we have all kinds of program logic circuits, and everything's written in different versions of Unix or Linux. I'm sorry, not Unix, and so much of what you do today is really the computerized building itself. You agree?
Yeah, that's interesting. I think there's certainly a lot of truth to that in some ways, especially when you're dealing with new buildings. Even when I started my career here in 2012, energy modeling, where you take the the plans and specs of the building, and then try to make this sort of software version of it and simulate the physics in the building to estimate how much energy it's going to use throughout the year. That was kind of niche, you know. It was sort of burgeoning, and now it's pretty much required for every project. So like the digital versions of buildings, you know, have become pretty much required or baseline. Um, and I think the same then is true for, you know, other elements. I think what's wild about buildings and architectural engineering and working in Chicago and other places in the Midwest and the Northeast and beyond is that also there's a lot more work in older buildings, you know, than people think. You know, we have people here that do forensics, you know, and just general upkeep on buildings. There's a ton of work out there because the building stock only turns over, like, what is it, 0.5% a year or something like that, maybe more or less. So there's a lot of older buildings that have really dumb systems. You know, I use this slide deck. It's like buildings are dumb and people do dumb things in buildings. You know, so there's also that reality that's the kind of fun. So whether you're kind of old school or new school or in between, I think there's ways to like find yourself in this profession. You know, and to find the stuff that interests you.
Yeah, I know some of the older specs I worked on buildings, we would do a test and balance, and if we were really advanced, we'd do one 6 months later for the seasons. In today's world, these automated building systems, the building control systems and that, they track everything and figure out certain weather conditions, what they need to do. And so it's a whole different automated world you guys are looking at than what I played with, say, maybe 40 years ago.
Sure. Yeah. At the same time, you know, at the same time, there's been most buildings that I've been into with any depth, you know, say we're doing a research project, a bunch of measurements on some intervention in a building or something like that. Most that I've been into, and my colleague, you know, Mohammed here, Hadir Nashad, has been in some pretty famous buildings in Chicago. Most of them, you get behind the scenes of the building automation system, and you go, what's that? Why is that reading that?
What did it do?
Yeah, and the answer is usually, oh, well, that sensor broke a long time ago. Don't worry about that.
Yeah.
And so there is this. I think you can't. You know, I think we can't get straight too far from your own roots, and I think that's important in our education too. And that you know, yes, we have a lot of sophisticated systems. We have a lot of unsophisticated systems in older buildings, but even the sophisticated systems don't necessarily really operate as sophisticated as you would think. There's multiple proprietary systems, or, you know, they don't talk that well to each other, or could talk to each other better, or there's you know, you can log data, but we don't bother logging data. Nah. So I think you find kind of a fractured landscape, I think is what we've called it before. It depends on the building and stuff like that, but I think what we like to stress, you know, here in the department is sort of no matter what, you got to kind of understand from first principles, you know, how building you think is supposed to work, or like what the driving forces are, what the mechanisms are, and you can't sit just behind the computer. So in that way, we're kind of, I think we have we can't lose your upbringing or your older school mentality, I think, or, you know, we can learn from those experiences.
I think one of the great strengths of us being in Chicago, and for the architectural engineers more so than anybody, is the internships we seem to find.
Right.
You know, and a lot of them seem to get really good ones.
Yeah.
So, you know, at this point, I'm going to.
Can we talk about the internships?
Sure, go ahead, talk.
We got to do that.
Well, then do it.
But the reason is because I totally agree. I mean, you see it. You know, some schools will have a co-op program where you take a year off or you intersperse this work experience, you know, throughout your curriculum. basically what we found is that if you come in as a freshman, we still teach AutoCAD and we still teach like engineering drawing, and it's a little bit old school. We still teach surveying to civil and architectural engineers, our two main bachelor's programs. But we do that so you can go home and get an internship in your wherever you're from, in your first summer. So maybe you're not working at the banana stand or whatever in the summer. Maybe you're like actually working on a surveying team or in an engineering firm, getting some exposure, And then by the time you get through your junior level classes, where you're learning to make and break concrete and that kind of stuff, you're really ready for an internship. And a ton of our students do that. By then, it's not uncommon that you're living in Chicago if you're not from here. And you spend a summer in Chicago on your first internship, or you go back home or go elsewhere and travel. I traveled for mine around that same time. And then by your senior year, you realize, well, I have Professor Lemming's class on Tuesday night, but that frees me up. My Friday is totally free. I could work a 6-8 hour day. You know what? I could do a 10 or 15 hour internship with the company that I was just interning with. And if you live near campus, I can take a bus, the green line, the red line, a divvy bike, a scooter, whatever. I'll be downtown in 10 minutes, 15 minutes, and work. And people end up juggling that. By then, you figured out how to juggle your courses and time manage and all that. And so it's just kind of become part of the culture where a lot of students will get an internship into their 5th year if they do like an accelerated master's. They even have usually a little bit more time. And then the same is true for graduate students. It's not at all uncommon that you come here, you take a heavy course load in your first semester. You can't do much else. You are getting fully immersed in the construction management program, for example, in the construction engineering and management master's. You're getting fully immersed and you're learning all these skills, maybe even into the spring. But by then you start to see a little daylight, and you can get you can get an internship and start gaining, like applying what you're learning from class, but then also gaining these like professional skills that are super critical, communication skills, critical thinking skills, ability to work on teams and all that kind of stuff. And I say all that because we have such a nice culture around internships that I just read we have something called a first destination survey. A lot of schools do this. But this is basically students who are graduating. What are you doing next? What you don't want to see on that is, I don't know. Right? Or like, I don't know, I haven't found a job. Fortunately, in our discipline, there's a lot of work out there. And so across our majors, from the data I've seen, we're at more than 80% of people who are finishing their program are going straight into a job or grad school. But if you sort by those who had an internship, it's basically 100%.
Yeah.
So it's that leg up that just gives you this extra connection. You may not even go to work with the same company that you interned with, but often you do. But it gives you this connection, and it gives you this work experience. That's the thing that employers always want, right? Well, I can't hire you. You don't have any work experience. Well, go get it, as soon as you can. So it's just so mission critical to us.
It's funny, I got one student this semester who a year ago had an internship in Texas, and the same company said, will you intern again this summer for us? He said, yeah. He says, well, we want to send you to Iowa now. Well, okay.
Yeah, and I've talked with a lot of employers. I mean, you and I always do the rounds at our career fairs and that sort of thing. Most of them know that the internship avenue is kind of you're both feeling each other out. They know they're not going to, win any new projects with you on board, right? They know that there's an investment and they may not recoup that in the same way immediately, but they're just looking for good fits. So you're getting experience, they're getting experience with you, and then you just see kind of where it goes. And then often, some of these companies we've talked to, right? Well, they may hire from many different schools and they meld them all together and see sort of how they work together and who's a good fit for their company, in addition to whatever technical skills that they bring to the table.
So with all that background and information, it's probably now a good time to hear a word from our sponsor, and our sponsor is us. So if you've heard something new about architectural engineering compared to the construction things we talked about in the previous interviews, or something kind of hits a chord here, if you look on the screen, our producers will be putting the link in there for applying here to IIT, or as we now call it, Illinois Tech, either as an undergraduate or a graduate student. But so we'll slip that in at this point. I think we've covered those things. The real thing I wanted to talk with you about, Brent, is AI. And you've sent out several articles, and I know in the university, at the faculty level, we've had some seminars in that. But I saw a very interesting interview with Jamie Dimon last week where somebody said, well, how many jobs are going to be lost to AI? And he says, I don't think any. Yeah. He says, I think you're going to see the landscape will shift, but you can't get rid of people. And he brought up the point that we've talked about before. You can't have a computer that's responsible. You can't have a computer that makes human decisions that you can't give that computer a professional engineer's license or a medical doctor's license to be responsible and make those types of decisions. And especially in my field of construction management, we're usually in progress meetings every week or maybe every 2 weeks because the projects change so rapidly that we have to constantly readjust. But, so I've kind of seen AI as really just a tool. And in one of the interviews that we had recently with an industry person, he brought up the point of granularity. And he said there's simple tasks that, yeah, we can replace some things, but he didn't see where professional tasks that we train and teach our people in are there. And I think that AI is not going to hurt our department, but our profession. What do you think?
Yeah, that's great. Great insight there. And it's a question I sort of struggle with a lot, but I can't help but come to a similar conclusion. I don't know if that's because of trying to, I don't know if it's self-preservation, I can't get over that, I don't think it is. I just can't really get it. So yeah, I think that's right, especially in when we still have this system where we rely on people working together and we rely on licensure. And licensure is critically important in engineering and design and construction and everything. So you have to have, like you said, you have to have this decision-making authority. It's got to run through people. There's sort of two things here. One is maybe AI just hasn't sort of, emerged well enough to overcome some of these things. That's what you can always say. And I see a version of that. I teach a class called Building Science every fall. And in it, we learn how to calculate a bunch of stuff. I always tell my students, it's not hard math. It's just constantly quantitative. We're always calculating. Nothing very hard. We just need material properties to do energy assessments, to do psychrometrics, heat, air, and moisture, and energy modeling is eventually where we get to go. Now, 2 years ago, I would put some of my questions into AI tools, and it couldn't answer them. It would block up even. Couldn't answer them. I thought, oh, good.
I'm not being replaced yet.
I'm not being replaced. This year, I can pretty much solve them all in some fashion, unless I just give too many components to it, which sometimes I do. But it solves them in a way that is completely different depending on the tool that you use. You get a different answer every single time that you use a different tool. You get a different approach every single time. you get an approach that I can now easily recognize when you're not doing the work yourself. I can see when you've done it via an AI tool. Can all that in another 2 years or another 4 years or another 6 years sort of overcome those limitations and replace a bunch of our calculations? Maybe in a way that I didn't foresee even 2 years ago. But still, at the end of the day, for a building to get built, and occupied, you gotta have permits, you gotta have licenses, you gotta have someone who stamps on that. And so if you're built on a house of cards where you've just used AI to calculate everything for you your whole life, and you can't actually have that intuition or discretion, then it's just not going to work. And again, maybe that's an element of self-preservation, but I think kind of more important than that, it's also just a world that I want. That's the world I want to live in, right? AI art interests me none. Art is about sweat and what you put into it, and the same is true for your work. And you want to be proud of your work. You do it from your brain and your own abilities. So I think that's something that we've got to figure out how to double down and triple down on. In higher ed. And we do have this licensure kind of component that is really critical. But really, just what's the point, of like a pure AI approach, and not really learning on your own. So yeah, I think that's right. I think there's a bunch of mundane type of tasks that in some areas, can lead to job loss, or replacement. But for the most part, I use tools when I very seldom use AI tools. It's to replace some mundane component of my work or life. Again, maybe there's more sophistication down the road in ways that I can't really predict, but I can't help but totally agree with that.
Well, I look at the project that we estimated this last semester in our estimating class, and it was a school, and the school had 120 geothermal wells in it, 400 feet deep, 70 heat pumps hooked up to it. And the question is, who made the decision to try to build this building with that in it? I mean, why? I just don't see those kind of decisions as an AI decision.
Right.
I can see saying, well, if I model it this way or that. As a matter of fact, on the weather at night, nowadays, the weatherman says, well, we use 8 different weather models, and the European model says it's going to get this cold, and the Tasmanian model says it's going to get that cold, et cetera, et cetera. And when we look at our profession, I don't see the AI as making that kind of decision. I'm going to put heat pumps and wells in.
Right. Maybe what it'll help you do, or what it is helping people to do, is gather information quicker to help you make better decisions, or to help make your decision quicker, maybe. So I was just talking to my wife about this last night, who's a lawyer, and it's similar in terms of profession requires licensure, and it requires people putting their judgment and opinions, online and all that. So making informed decisions and working in gray area, AI is not good at that, right now. But so I wonder, if you're running a design firm or a consulting firm and you're bidding projects, does it basically just help you bid for more projects? Does it help you sort of execute more in the long run, because you could just do stuff more efficiently? People talk for a long time about like the end of work, as we know it, right? Because we get so efficient that we don't have to work. But has that happened? No.
Not yet.
Not yet.
I've tried to retire a couple times. I kept getting drugged back in.
Well, they won't let you. Yeah. There's other forces at play, I guess. So yeah, I mean, I think there's we did hire a new faculty member, just in the last year, Kayun Jung, who brings AI expertise, but has used it for interesting stuff. I have 10,000 pages of documents. How do you want to look through them?
Yeah.
And certainly she is helping the construction industry like bring those tools to learn something, but ultimately make a decision based on that, right? And that's still human. And again, I'm not super interested in a world like lacking human decisions. Are we even people anymore? What's the name of this podcast? It's like, where are we going?
We're not automating the Dozer. We're not going to let them out there by themselves.
Yeah, although there's a lot of automation in Dozer.
There is.
Right? Yeah.
You can hook them to GPS, and you can get the grade down to a quarter inch nowadays, and you can actually do it from 1,000 miles away if you have contaminated soil in that.
Yeah.
As a matter of fact, the demo they do at Caterpillar, the very last when it comes in, I think it's a D10 or D11, starts pushing dirt inside this demonstration building, and then when the lights come up, there's nobody in the seat. And then they show you the operators right in the middle of the grandstand.
Yeah.
Yeah.
So you still got an operator, but they're
Yeah. Well, when it comes to AI, though, one of the things that we've talked about a little bit is this term work slop.
Yeah.
And it's something we're seeing in the business world where students are learning to use ChatGPT, or they're using something else to write answers, write papers, come up with things, and they're not competent when they go to their job. And the people running the company need something done that's has a financial background to it, and the student gives their boss this very pablum answer without any type of analysis or decisions or whatever. And I've been reading recently that Generation Z is having a very high rate of firing because they're not teaching this. And I think it's made me reassess what I'm doing with my own students to make sure that instead of just asking for an answer, tell them I need you to give me what the alternatives are and what's the best alternative and why.
Right.
Which is what you have to do out in business.
Right. Yeah. And I want to make sure and use a moment here to applaud your approach, an approach you've taken for many years in some of your courses, in terms of setting that bar high. Just I think earlier this week, maybe last week, there's a Washington Post article about more and more faculty at universities like turning to oral exams in the face of AI, because we just don't want to. We have to create critical thinkers, and we have to avoid sort of this spiral of a student can pretend to work, we can pretend to grade, they get a worthless degree, and nobody wins. Like we're not going there. We can't go there in engineering. Society doesn't need it. Ethically, we're not there. So. Just for many years, I've had a chance to sit on these a few times. Professor Lemming and his colleagues, when they run their I would call it kind of a flagship class, the Construction Methods and Cost Estimating course. I think it's a true flagship of this department, and maybe just because it's been planted so long, but it introduces you to all the different areas of construction and the specifications, divisions, and all that kind of stuff. You understand how to immerse yourself in plans and drawings, and you estimate the cost of a project. And you don't just turn it in. You don't just use AI tools and hope you get an answer. Don't get found out that you cheated. Professor Lemming runs a 2-day final exam, about 20 plus hours of exams, where each team comes in and presents their project, and you just inquire about their methods and their assumptions and their own work, and and it's great. The glasses come down, and the plan gets up here, and line by line, line by line. I love it. And if you've taken any liberties, you'll get found out, because that's not the point. The point's to learn and to develop a set of skills and core competencies that translates into the work world. So I just want to applaud and commend you on that for being kind of ahead of the curve by sort of, maybe going back to the future.
By osmosis.
Yeah, it's a sight to see, and a flagship course, really.
Well, many, many years ago when I started teaching, in the business world, in construction, engineering, design, you spend a third to half your time trying to get new contracts. And that means that you spend a lot of time putting proposals together, and you want to get what's called shortlisted. If you get in one of the top 3 proposals, then you get to stand in front of somebody and sell yourself.
Yeah.
And you got to get that work in the door. If you don't, baby doesn't get new shoes. And so I don't think any student understands that they're going to walk out of here and suddenly find themselves doing as much marketing as they do engineering.
Right.
And that's the way it is. But that's why I put that course together, 38 years ago now, with presentations of to an owner and that. And so I know you also teach the freshman course on introduction to the profession.
Yeah.
And I would almost suggest to you that you had the first day or two, have them take out a sheet of paper and write an essay on why do you need me as a professional engineer as opposed to AI?
Oh.
See what these incoming freshmen are thinking.
Yeah.
It'd be interesting.
Yeah. Oh, yeah. Yeah, I do very little with AI there. I like that. And I really enjoy this course. It's really for first year, freshman students. So I teach it as a department chair mostly, so I get to know everybody at least some level. And in their first semester, we do a lot of skill building and learning about the university. The librarian comes in. We have an engineering librarian, and he comes in and tells us how to find information and how to find out when information is disinformation on some level. So really cool. And at the heart of every university is a library, right? That is so key. They learn about a licensure and ethics in the profession. We have an engineering ethics kind of set of modules that we do. We learn about infrastructure systems and history, infrastructure throughout history, and then they kind of culminates. There's a few other skill buildings and modules and stuff like that, but it culminates in they do an engineering failure analysis. So I have them pick some project where something went wrong, or in the case of the city core building, something almost went wrong. And they just pick one. It's pretty, it's usually around the built environment, some kind of dam or transportation failure, usually a structural failure. And even though they're freshmen and they haven't had statics, mechanics, materials, and all that kind of stuff, I just want them to learn about how to go find information, go try to understand, an engineer's report on a failure. And they do an amazing job. And I detect very little AI right now. Maybe that'll change.
Maybe.
They do. I'm really impressed. They bite off some really tough projects. One group did a love canal this fall and got into all these social, political, and technical dimensions of this issue of hazardous waste dumping and.
That founded the EPA.
Yeah. It's really cool what they're able to put together, and so far it's a largely AI-free environment, from what I can tell. And I think that's part of why people get a lot out of it. Yeah. The Metrodome roof collapse is always a good one. The This sort of inflated roof, where the Vikings
And the snow gets
play,
on it.
and the snow gets on it. It's a really good one because then they're getting into if they do it right, they find the test reports. Luckily, no one got hurt, so it's a good one from that perspective.
Yeah, unlike the Hyatt disaster.
Exactly. The Hyatt gets picked pretty much every year for sure. And these students are looking at the intersection between construction and design, engineering, and construction, and where stuff can go wrong, and they do a lot. But yeah, that's next thing you know, they're looking at material sample reports and strength testing reports from the National Institute of Standards and Technologies, and I'm just glowing because you're a freshman and now you've heard of NIST.
Yeah.
Like this is what we're talking about, people.
Kind of related to that, but several years ago, I had the chief design engineer at the MWRD came down, and we had picked one of the preliminary projects we were working on for the capstone to play with and to look at. And he came down to talk about where we were at. They started asking him all kinds of technical questions about this project. I don't know. He said, what? You're the chief designer. He says, yeah, but that's the interesting thing about engineering. A lot of times we just don't know. And
Wow.
we got to go find some of this out. And he says, and those are some of the things we're going to find out as we keep going forward with this design.
Yeah.
The class was a bit, as seniors, taken back that
Yeah.
that the world isn't this perfect equation out there, that there's so many variables that we still play with, and we try to make good assumptions.
Right.
But,
Right. Yeah, that's our, every engineering program, if they're accredited, they have to have some kind of senior design, sequence or class or whatever, some kind of senior design experience. And so we tinker with ours every once in a while. And I know you've heard about this, but last spring, we teach ours in the spring. We had this super cool experience where the lead instructor connected this class of 55 students or something like that with a construction company, and one of their one of the staff members there is an alum from our department, and they were kind of the overall lead and coordinator with this big project around the redevelopment of the United Center, which is where the Bulls and the Blackhawks and a bunch of concerts and stuff, where all that happens, just on the near west side here. And it's just surrounded by a parking lot. Like, it's not very interesting. It's nowhere near the kind of level of use and utility that a lot of other stadiums are, even Wrigley Field, immersed in the neighborhood. There's just not much around it. So there's this huge amount of investment and design going into redoing that thing. And it was really cool because basically every group, half a dozen people might be interested in construction management. So they could work on that aspect of this redevelopment project. It was pretty early on, in the overall process. So they kind of got to get in there early. The environmental engineering, students did the site civil, drainage kind of work. Then they had to work together and understand that, like, oh, well, that's going to intersect with some of the structural work on this building. This stuff clashes. Oh, man. Well, at least they're working together and understanding it. But ultimately, what their outcomes were to evaluate alternatives, right? There's not one answer. There's infinite answers of how this transportation should be done around this new development. And they had to kind of distill it into maybe 3, 4, 5, 6 different options when you don't know that much yet, And it was a cool experience in part two because there's so many disciplines involved. It occurred to us that we don't have all the expertise on our faculty for every aspect here. So we hooked them up with a bunch of mentors. I think there were 22 industry mentors for 55 students when we ran it in the spring. So each team that was focused on some area could then kind of link with a mentor or two and meet with them regularly. Most of them were local. I think all of them were local. And just kind of get that flavor. So it was a really cool experience. But I really did love it around evaluating alternatives, and that's something like in my junior level class. I do try to get into, okay, we're going to do a calculation. We're going to do this heat transfer calculation. Go look up in a table, what this value should be. It has a range. What should I pick? Yes, it does. Let's talk about why you might pick which one you might pick. Let's talk about the repercussions of not picking just one number. Should you go conservative or should you pick a middle number? And that is just kind of the beginning of approaching engineering analysis eventually for design, because you got to make decisions when you don't have all the known information, right?
Yeah, it's on an old project I've worked on. Somebody says, "Why did you do that?" My answer is usually, "Because I didn't know any better." Well, listen, we're kind of getting to the end of our time. Is there anything else you'd like to throw out there in either architectural engineering or in general? You've covered some broad areas here. Is any lasting thoughts that will burn like embers in the souls of our listeners as they wait for the next video to come out after Christmas?
Oh, yeah. Do you know who's next?
I'm going to do the next one.
Oh, you're going to do the next one.
I'm going to talk about our research models.
Okay. Yeah.
That's going to be my next video.
Yeah, I like that. No, that's a good question. I mean, yeah, we did cover a ton. But I really think that the main element that we're seeing here is that the thing that I've really loved about working here, and why I think it's such a great way to prepare for your career, is that what I see is students don't just want to get like a job. That's not where we are. It's what I want students to do is to get like a great job and prepare for a long-term career. And I think that's what all of us are really, really focused on. Find what you're passionate about. We're fortunate in that we work in the built and natural environments such that generally we're trying to make people's lives and worlds a little bit better in some way. We may make it worse for a little bit, but we try to make it better in some way. Try to understand how stuff works, So I think that's really key. I would say that there's one last piece of like anytime you intersect with us. When I started here as a tech school, I thought, this is going to be a bunch of engineers, and it's going to be a bunch of people looking at their feet, like I do when I walk, looking down at our feet. And what I found is a much like richer, looking at our phones maybe, but a richer and robust environment that everyone is learning some technical skill. And yeah, there's variability in like the knowledge and technical skills that they come out with. But for the most part, we're all supposed to be at the same, level, or at least within some range. But what really I've noticed our students separate with is we're so active in student organizations. We're not a big school. We're small enough that a lot of us do have kind of an open door policy. You get to know your professors, and that's really important. We got a whole bunch of adjunct faculty who work in the profession and teach us how to do things. Plus, you've got the PhD faculty here who teach us how things work, and that combo is really good. But at the end of the day, students get really active in student organizations. You guys see MAA, the Construction Management Association. Our American Society of Civil Engineers group is big. ASHRAE is big. A lot of times they work together and they bring in speakers. At the end of the day, I think the one thing I think puts a fine point on what I like about this department and its people is that our students have run their own career fair for 11 years now. There's a big university career fair. There's actually 2 of them, but it's university-wide. It's all majors. And then some employers like a more boutique kind of version of it. So 11 years ago, our students got together with our career services group and just started their own. So we can accept about 30 companies at max to fit in the room that we have. And it's just one-on-one with CAE, Civil Architectural and Environmental Engineering students and all that entails. But our students really run it, so they're more social than I would have thought. That was my point. And I think that's really important because that's what you need in any industry, but especially in the AEC industry, right? You got to talk to people, you got to convey your ideas. work within conflict and all that kind of stuff. So definitely encourage you to, if you're working locally and you want to present to one of our classes, like reach out. Maybe something will work out. If you are working locally or semi-retired or whatever, and you want to teach a class, reach out to us. Like, well, let's have that conversation. If you want to get in on mentoring a student or an organization or something like that, reach out. Or if you want to apply here to pursue a certificate program or a master's program or whatever, we've got a lot tailored kind of to each area of CAE. And Professor Lemming, you're a huge part of it. So thank you for having me.
Well, thank you, Brent, and thank you for your time today. And at this point, we're going to put up the blob again on the video. It tells you how to get further information about enrolling here, or even to email us at our custom email that we got given to us by the OTS people, and hopefully it'll work. But thank you again, and we got the holidays ahead. The shortest day of the year is in a couple days here, and people are going away, but we'll all be back in the first of the year. So thank you very much.